you telling us in the state?
No, I mean, we have 2 hours for class. I would highly recommend everyone get there on time. Hint, 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 right? So you can fire up your incinerator, you know, process your thoughts, fill out your scrap paper.
You think you could open the doors up early so we could write out like our flow charts and stuff like that if we get to like at 7:30, or that's too much? No.
Probably not, because I'm not gonna be able to do it for the 10 a.m. class, because you guys are gonna be in there.
Gotcha.
Yeah. Yeah. And we'll talk about maybe some strategies about, you know, how you might want to approach that, what the rules are. All right, one more lab we did.
Oh, that's so cool.
Under strep, we did, what did we do? Alpha and gamma. All right, what did we do? We did Taxo-P.
That's the 13, 14.
That was our oxygen.
Yeah.
We did bioescalin. And we did 6.5% sulfur. All right. Let's talk about Taxo-P susceptibility. What's the zone size for sensitive?
That one's 14.
All right, so 14 millimeters. Oh, okay. Can you guys see it all the way over here?
Yeah, it's workable.
So 14 millimeters or greater is going to be susceptible. Less than 14 millimeters is going to be resistant. Good. Bioescalin. This was our slant. We just squiggled our bacteria. There's a bioescalin slant sitting in front of you. What does a positive one look like? Dark. Almost black, right? So that SQVT. Negative? Yeah, like a beige or gold color, just like it looked like when we started, but you won't have that, right?
Yeah.
This will probably be multiple stations, and maybe just see what the different options are. It's either dark brown or gold. What do we look for broth, or salt broth? Turbidity. So if it's cloudy,
Yeah.
positive. If it's got good clarity, negative. Is it coming back? Again, the color atlas and the textbook are good resources to refresh your memory. You know, because time tends to, you know, you forget things, and you get so consumed with the newer stuff, you lose track of your earlier stuff. So the atlas is a wonderful resource. So where are we adding this to the flow chart? We're going to be up here under hemolysis. We're going to head over here to alpha or gamma. I'm going to lump them together. Let's start with Taxo-P. And we've got sensitive or resistant. Which of our streptococcus is sensitive to Taxo-P?
Streptococcus pneumoniae.
Streptococcus pneumoniae. Good. Fabulous. If it's resistant, what are we gonna look at? The bioesculin. Alright, if it's bioesculin, let's go this way. We'll go negative over here, we'll go positive over here. If your bioesculin is negative, what do you have? Strep what?
Is it group D?
That's it, viridans. If it's bioesculin positive, we need to take a look at the broth results for salt. And you can have cloudy, or you can have clear. Positive, Enterococcus, excellent. We'll just say Enterococcus species, that'll work. Negative?
Group D strep.
Yeah, so group D, non-enterococcus. Why do we do this to ourselves? I don't know. So the stations are more than just interpreting the results, but it's also applying it to the flow chart. Now, this is a flow chart. You could take the same information and put it in a table form, right? You could do a tabular form. And in most of the handouts, I think I give it to you both ways. My brain works for flow charts. Yours might work better with tables. I mean, you could, I wouldn't really do flashcards necessarily, you know what I mean? Like flashcards could give you some of this, but I don't know if it could give you the big picture. But you could on a flash chart, you know, just go gamma strep, bioesculin positive, salt positive, resistant to taxophage. And then you could take that and apply it to your flow chart and see if you get to the right answer, which would have been Enterococcus. And there's ways to do a little of both, or what you remember for the table. But let's talk about strategies. So the question was, are the stations timed? No. There are 17 stations. There are more stations than students. So there should always be an open station to go to. Maybe towards the end we get a little bogged down. But really the only rule is one student at a station at a time. And then if there is a student who's kind of like set up camp there for a little too long, might ask them to move along to let others have a chance, but they can always return. So it's not like one station, one shot kind of a deal. If you want to go back and revisit a station a second or third time, do it. As long as it's open. Like I said, if it was me, I'd probably go in and start doing the flow. I would write my flow chart down. I would put whatever other notes I want to throw in there, like, I don't know, oxidase of purple. I don't know, whatever I need to just put out, I would write on my little piece of scrap paper before I started looking at the question. Not only can you like go to the station as many times as you want, you can approach the test any way you want. Maybe you want to start with the grandstand. Maybe you want to start with the short answer questions. Maybe you want to start with the stations. Maybe you start with a couple stations and now you're considering using one and you want to go back and make your smear. You can do that. You know what I mean? Like you decide how you want to approach the test. I mean, I wouldn't wait to the very end and be like, oh, let me flip on my incinerator now and do the grandstanding if time is getting short. You know what I mean? Or you might get frustrated with some of the questions and be like, all right, I'm going to move on to the grandstand. I'll return some of the questions later. We are going to be limited to our time frame, 1 hour and 50 minutes. So just think about how it's doable. Just think about how you want to approach the test. Questions?
I have a question. Do you have to go, like, you can start with the short answer if you want to just start, you can go at whatever, literally.
And you can go from station 12 to station 9, you
And
can
then
jump
just have
all
to do your
over,
brain stains and then go back.
do however you
Okay,
want.
cool.
Do you know when you have one piece of scrap paper?
Yeah. If you run out of it. We'll start with one.
I know in these packets you have like list some diseases that are, you know, part of that bacteria. Is that also in the
Could be. Yeah. And I might not say, maybe I might say this too. You know what I mean? Yeah. Yeah, some are very specific, right? Staph epiphthicus pretty much only causes urinary tract infections. Like, as you try to answer those questions, you'll see that. Like, this one's almost only urinary tract infections. Aureus can be almost anything. If I asked you that one, you could write anything down. You could be like, anything from like gastro to meningitis and everything in between. It does everything, unfortunately. What's another one? Pyogenes, you know what that one does, right? Strep throat, cellulitis, necrotizing fasciitis. Urinary tract infections, spontaneous abortions to the fetus. Herpes, nasty. Potentially. Yeah. What does strep pneumonia cause? Pneumonia. Other things like pink eye, sinusitis, meningitis in the elderly. But I would ask you for all of them, just like list 2 or something. With that, those kind of things. Whatever's in the packet. Are there questions in the packet that you've been unable or unsuccessful in addressing?
I know there was one, that was
So it's on the miscellaneous question sheet. It's the last question. It says, since you can't identify bacteria from a gram stain, why might the physician prefer a gram stain sample before prescribing antibiotics?
Excellent question. I wish I wrote that myself. Oh wait, I did. Everyone hear the question?
No.
It's basically, since a gram stain alone does not give us or the physician the genus and the species of the bacteria, right? It gives us a place to start. On positive calcite, we're going to start doing our catalase and we're going to move on. But why would a doctor be interested in preliminary gram stain results from, say, all right, they don't often do this, but let's say it's a urine culture. And it's going to take us, probably 18 hours or so of incubation for us to even have a clue what the bacteria could be. Why would a gram stain of that urine sample perhaps be helpful to the doctor? What if we tell the doctor it's gram positive this or gram negative that? There are some antibiotics that work pretty darn well against gram positives. And then there's another group of antibiotics that work pretty darn well against gram negatives. So sometimes just that information, if we found predominantly gram negative stuff in the sample, or predominantly gram positive stuff in that sample, I think the physician might just be able to fine-tune an antibiotic option rather than always going broad spectrum, broad spectrum, broad spectrum.
be a way to get like a gram negative when really it's a gram positive? And how would you know that, or like to know to re-perform your gram C? How do you know if you need that state and it really should be positive and it's not negative? Cause you wouldn't make 2 slides for everything you do. Yeah.
No. So, in real life, when you're out there as a practitioner, we hope you perfected the gram staining technique. And in real life, like, then you look at the bacteria growing, and you're like, you're gonna get to the point where like, that looks like staph to me, but my gram stain said gram negative, so something's wrong. Either my gram stain's wrong, or that's not staph. So you might repeat it, you might have a fellow employee repeat it. You look how old the plate is it fresh, that kind of stuff. Because yeah, you can take something that's supposed to be purple at the end and end up with pink. And vice versa. You can start with something that's supposed to end up pink and it's still purple. And it's all about that decolorization step. Either you put the alcohol on too long, or you didn't rinse it with water fast enough after it did start turning colorless, the runoff. Or you didn't let a little purple run off that you should have let run off.
I think last week I put too much decolor, or I didn't hit it with the I think my slides were too close together, so I think some of the decolorizer got on one slide and I didn't notice that.
So it's sat there too long.
So it sat there too long, and so that's what I was wondering, like, obviously we didn't know what we were looking at, so, like, is there a point when I'm doing it that I could have noticed, like, that I should have to repeat it, or not really?
Well, you won't even know. I
Yeah.
would say if I was doing the gram stain and I saw pink and purple cells right next to each other, I got one side of my slide pink, another side of the slide purple. I'm definitely redoing it.
Yeah.
Right? Either one side got too much alcohol too long, or the other side didn't get alcohol enough. Right? We're taking our specimens from pure culture, meaning there should be one bacteria type. When you've got 2 drastically different gram reactions, that's a good sign to repeat the test. You need to start from scratch. If I've got like this section has pink and purple together, this side has pink and purple together, this side has pink and purple together, like it's scattered pink and purple everywhere, either my cells are old, or I don't have a pure culture like I thought I did, mixed. So I would re-examine my Petri plates, make sure everything looks uniform, and literally repeat it, taking one colony. I mean, I did look at your slides today, a lot of them pink everywhere, right? That means you took a lot of bacteria, which is okay, but it's risky. If you just take one colony, you still have 500 billion trillion, whatever it is, cells. You got tons of cells. It's hard to do the microscopy that way, you know what I mean, because it's such an isolated little spot. Then you know you have one colony, you should have one outcome.
Mine was a little.
Yeah.
And I
It should be
remember
uniform.
it. I remember the decolorizer, like, me going like, oh, I think it got on that.
Yeah. When we make thick smears, it's hard to evenly decolorize because there's so many multi-layers of cells. You know what I mean? Like some cells are gonna just soak up more alcohol than the other. You know what I mean? Like it's hard to get a nice even distribution of the alcohol.
No, but that is helpful, so thank you.
Any questions? All right. Mathematically, your lab exam is worth 15% of your course grade. If I remember the syllabus correctly. That sounds about right, doesn't it? 15, 30, 60, yeah. 15%. Oh no, at the end of the semester, you'll have a lab final. Yeah, so you have 2.
And is it cumulative?
No, so lab exam 1 covers obviously just the first half of the semester. Lab exam 2 will cover just the second half of the semester. So when we come back from spring break, everything from that to the end of the semester will be our test, lab exam 2. So the lab exam is weighted, it's pretty chunky for your course grade, but that's fair, right? You're gonna be Gotta know the last stuff. I mean, I gotta know the lecture stuff, too, but you gotta really know the last stuff.
But the lecture, I read in this syllabus is cumulative, right?
The final is, yeah.
Yeah.
Thought I saw another hand. Is there another hand? Alright, so I hope this made you feel better, not worse.
I feel better, so we have an idea, yeah.
You have to memorize all this, so you can write it down.
Yeah.
No, but I think it's good, because then we can take more time to digest. all the
Yeah.
information
Absolutely, yeah.
and break it down.
Instead of trying to cram it all in, and a little more,
We only get a day.
No.
yeah, 5 days.
Yeah, we got 5 days.
No, a week, 6 days. We're okay with that.
Almost a week.
Almost a week. Alright. So don't be